This is Team 4 of 4 members Srihari, Shivani, Amit, and Avantika. We are creating Xylophone Bot as our engineering exploration course project. Problem definition. Our objective is to design a user-friendly bot which is not more than a kilogram and occupies maximum space of 18 into 12 into 6 inches. It should play at least 2 tunes and should work under 3 different modes of operation. Next is function tree and function clustering. These are the functions which will be performed by the bot. First, the modes and the description will be displayed on a screen. Then, the user will give input to select modes. Then, the sticks will move according to the mode selected and strike the xylophone plate to create tune. The machinery of entire system will be placed in a proper casing and the sticks and xylophone plate will be held with the support. Thus, we can cluster these functions accordingly and divide them into subsystems. And the identified subsystems are stick handling unit, user interaction unit, casing and xylophone handling unit.
We have generated four different concepts. In the first concept, four servomotors are used. Two servomotors responsible for the horizontal motion and the other two are responsible for the vertical motion of the stick. In the second method, cam and follower is used. DC motor brings the rotation motion to the cam and cam brings the vertical motion to the stick. In the third concept, seven servomotors are used. Each motor holds each stick and brings the hitting action between a particular stick and a panel. In the fourth concept, rack and pinion is used. The DC motor brings the horizontal motion and the stepper motor brings the vertical motion to the stick. And we have selected first concept.
Now let's move on to the virtual implementation part. The first is 3D modeling of entire system.
This is our 3D model of xylophone bot. This is a base which is made up of 10 mm foam sheet, and this is where we place the xylophone. This is the servo base holder which is made up of acrylic sheet of 5 mm thickness. The, the servo base holder and the base will be connected using the L clamps. This is the upper servo holder which is 3D printed. This is a clip which connects the stick to the upper servo. The stick, the clamp, the upper servo and the upper servo holder together make the striking unit.
This is the circuit of entire system consisting of 4 servo motors and a Bluetooth module connected to Arduino Mega board. This is the flowchart of stick handling unit which shows how the 4 servo motors will operate according to the text received by Bluetooth module. The servo will move 10 degrees for horizontal movement and 40 degrees for vertical movement of sticks. This is the flowchart of user interaction unit that shows how the text will be sent according to the mode selected by the mobile app.
This is the bill of materials that will be used to create this bot. It specifies the quantity, specification and fabrication of each parts. For the system to operate effectively and safely, according to the calculated torque mg90s will be the servo required, so the bot will draw current of 700 mA at an operating voltage of 6 volts.
These are the functions to be performed by bot. First, the machine is switched on. Here the sticks will regain their initial position. After that, user will select the mode on the app as shown. Suppose the user selects option 1, text 1 as a form of digital signal will be received by Bluetooth and the servos will move accordingly to play Happy Birthday tune. The servos responsible for horizontal motion are termed as D1 and D2 that will move 10° each, and that responsible for the vertical motion or striking the plate are termed as U1 and U2 which will move 40 degrees.
Now, let's move on to the simulation part.
This is a circuit of our xylophone board. We have used Arduino Uno. These are two breadboards. We have used 4 servos, 2 bottom servos and 2 upper servos. We have used 9-volt battery to supply the power for 4 servos and the buzzer. We have used buzzer as a xylophone. These are the 2 buttons used to play jingle bells and the happy birthday tune. This is how our simulation works.